Hi guys, it's Mrs. Bybee. We are going to be doing a end of year power review. We've learned about heat, we've learned about microorganisms, we've learned about sound, we've learned about our solar system, we've learned about a lot of different things this year, and it's hard for us to remember sometimes all of that stuff that we learned way back when. So when you watch this video, you will have a little refresher on all that information so that you will be prepared to take your end of level test. So thank you for watching, guys. Okay, first off, we are going to be talking about heat and the way heat transfers. So we need to kind of backtrack a little bit and know what energy is. Energy is the ability to do work. So you need to remember that energy is the ability to do work, and we have many different types of energy. Now, here are a few types of energies that we have. We have light energy right here. We have atomic energy, mechanical energy, chemical energy, electrical energy, thermal energy, which is what we're really going to be focusing on right now, and sound energy. What is heat? Heat is basically the transfer of thermal energy. So whatever is warmer is going to be transferring the heat into something that is cooler. So remember when we were talking about if you hold hands with somebody and somebody's hand is cold, we call it cold. But what's really happening is that the heat from the warmer hand is being transferred to the other hand. This shows us an example of this. Remember when we had the ice cube and we put it in our hand? That was actually showing us conduction. But the heat was going from your hand to the ice cube. Eventually the ice cube would melt and it would become a liquid, and you could have the thermal equilibrium where they are the same temperature. But remember that heat always goes from something that is warmer to something that is cooler. We have two forms of energy that we've discussed: potential energy and kinetic energy. If you remember, kinetic energy is associated with movement. So those molecules are really moving. And I put it into relationship to a roller coaster. If you are on a roller coaster, the potential energy is when you're on top, right? You're not quite going down yet. You're just waiting before you go. And the kinetic energy is when you're going down, all right? So you're going to have more kinetic energy when you're going down than when you're sitting on top, which is potential energy, okay? Now remember, all matter has atoms and particles inside of them. And when they are heated, they start to move a lot quicker. So in this diagram, you can see when they're cold, there's not a lot of movement. But when they're hot, there's a lot of movement and they're bouncing off of each other. And then we can kind of see from this, if this was actually a GIF image at one time. So when they're heated, you're going to have that movement of them going a lot quicker, which means your kinetic energy, what's associated with movement, is a lot higher. It's increasing. This felt like kind of like a trick question at first when I asked you guys which has more thermal energy. Here's this giant ice sculpture and here's this little teeny match. And most of you guys were saying the match did because you're thinking heat, thermal, that's got to have more thermal energy. Actually, it's not. Remember, the bigger the matter, the more atoms it's going to have, more molecules it's going to have, and the more thermal energy it's going to have. Now, if I took that match and put it up to the ice sculpture, the match would run out before it melted the ice sculpture because the ice sculpture has more thermal energy. Now, it's not moving around as fast as the match is. The molecules in the match are really moving because it's really warm, but the ice sculpture does have more thermal energy. Look at these cakes. Back to the same thing. The one that has more thermal energy is probably going to be a larger item that has more mass. So in this case, we have a small cupcake and we have a large cake. The cake has more thermal energy. And remember, thermal energy is the total energy, potential and kinetic. So please remember that thermal energy is the total energy, potential, and kinetic energy combined. We have three different types of heat transfer. We have conduction, convection, and radiation. And we're going to discuss with what each of those are to help you remember how we learned it in class. So we had three things that we showed. We showed a mood ring that you put on your hand, it usually changes colors, a lava lamp, and a space heater. And we know that conduction, remember, conduction, contact, is the contact. That's demonstrating the ring in this picture because the ring would change color when you have contact and then it would heat that ring and change its colors. Now, the convection is the movement through a liquid or a gas. Convection, movement of through a liquid or a gas. Just like this lava lamp, it's moving as it's being heated. That wax inside is being able to heat and then move in that lava lamp. And radiation, remember, how did I do that? Radiation, no matter. The space heater represents radiation because it doesn't have to go through matter in order. It can go through a vacuum. So think of the space heater, think about the sun shining down. That heat that's coming down doesn't have to pass through anything. That's radiation. So tell me, which of these methods of popping popcorn shows conduction, shows radiation, and convection? Think about that for a minute. Give you just a little bit of time to try to bring that information back out. Okay, so the popcorn on the stove is showing conduction. Conduction, contact, conduction, contact. That pan is on the stove directly. The stove is heating the pan is heating the popcorn directly. Conduction. Convection through a liquid and a gas. So you're showing the popcorn popper demonstrating that. And radiation in the microwave, it doesn't have to go through any matter to get that heat. All right, here's conduction, radiation, and convection in the atmosphere. We're going to start over here on the far right. You see the sun that is, the sun's heat is traveling through space. Remember, something, no matter. Something, no matter. Which one is it? If you said radiation, you are correct. Good job. Now, we're going to move on to this next one right here in the middle. We have hot air rises and cold air sinks. Which one's that? What do you think? If you said convection, you are correct. So, moving through a liquid or a gas. Now, going on to the far left is what it is. We have the heating of air over the road causing a mirage. That's conduction. So, conduction, contact. You have that contact right there from the road getting into the air. And this just demonstrates the convection aspect of those ones that we were just looking at. The warm air rises and takes the heat with it. Eventually it cools and sinks, just like the wax and the oil in a lava lamp. The hot and warm air move by convection. So the three ways that heat transfers is convection, radiation, and conduction. Convection, think about the lava lamp, or convection, movement through a liquid or a gas. Radiation, no matter. So an example of that is the sun's heat going onto the earth. And then the last one we have is conduction, which is contact. So you might think about the ring. So conduction, contact. And for the last part of the heat section of your review powerhouse videos, I want to ask you guys, is temperature different than heat energy? Think about that for a second. And I have yes or no. What do you think? Well, it is actually different. And if you remember from our lessons, that thermal energy is the total energy, potential and kinetic. Temperature is the average kinetic energy. That wraps it up for heat. Let's move on to the next one. And this concludes our heat section of our SAGE review. Next, what you need to do is look at the questions that are right after this video and make sure that you answer those. And then you can move on to the next one. Thanks, guys.